Okay. Good afternoon, everyone. Welcome to the first webinar of this year's Summer of Weather Code, run by ECMWF. For those who don't know what ECMWF is, it's the European Center for Medium Range Weather Forecasts, and we are both a research institute and a numerical weather prediction organization. So we have numerical weather prediction models, and we run it on a 24/7 basis and provide a forecast to national weather organizations and our member states. So the Summer of Weather Code is a collaborative program where we invited this year startups, developers, scientists and students to work with us for 4 months during the summer on innovative and new weather-related code. Summer of Weather Code run the first time this year, and since May, 5 teams teamed up with ECMWF mentors to innovate weather-related code. And today is like the first version of this week of webinars where we want to show the results of all the 5 projects. And one of the projects there was developed a enhanced GIS widget to select areas on maps, and it was developed by Predictia in Spain, and the ECMWF mentors were Marta and Megan, who are here to the left and the right, and yes, and the core developers were Fernando Martin, Markel, Garcia, Diez, and Diez and Martin from Predictia. And now I hand over to Megan and Marta, who will talk more about the motivation of this widget and the project.
Okay, welcome to the Enhanced GIS widget program for the Summer of Code. As my colleague Julia has presented, I am Marta Gutierrez. I am one of the mentors together with Megan Plumridge, and we've worked very nicely with developers in Predictia, Fernando, Daniel, and Markel. So yeah, I'm going to go through what we've done. This is what we're going to do. We've worked very nicely on a team, so we're going to do a team presentation, and this is our agenda. I'm going to present myself, the motivation and the requirements for this project. We're going to hand over to Predictia, who are going to do a live demo. And then we're going to come back to us, and my colleague Megan is going to do what are the plans to integrate this widget at ECMWF, how we've worked together with Predictia, and further developments that we would like to see happening. So as part of the motivation, I'm going to explain a little bit of the basics behind how and why we wanted this widget to be developed. So to start with, ECMWF has a definition language, where we express meteorological requirements. And with these requirements, we can obtain the forecast data. In these requirements, we define a geographical area in the world. As my colleague Julia said, we provide numerical predictions. We are a global model, but some of our users, they're interested indeed in sub-areas or points of the forecast. And this can be configured by expressing latitude and longitude coordinates. So how do we express this in our convention? We define north latitudes, west longitudes, south latitudes, and east longitudes. And this is what we call a bounding box. And equally, we define the points by expressing the latitude and the longitude. And this is where the main motivation came for this project, is that very often the users request the wrong coordinates, potentially leading to expensive computations of incorrect areas. So our proposal in this Summer of Code GIS widget was to have a web-based map for the selection and display of geographical shapes, so that the users can preview the areas that the data covers, and therefore we could minimize the errors, and we would make the data provision more transparent to the users. We quite like the idea that it was an open source project, as very often the technology for a web-based map is JavaScript, and these libraries, they get out of date very quickly, and they are very sticky to particular versions of browsers. So the fact of having an open source community behind it that can maintain the project, it made it very appealing to us. And equally, we wanted this widget to be configurable for different web applications here at ECMWF or anywhere else that would have a need for this functionality. So these are the requirements. We wanted to select areas by drawing on maps, different shapes, polygons, bounding boxes, and points. We wanted selection of locations, like for example, cities or countries. We wanted to draw, expand, or reduce an area either on a map itself, or we wanted this functionality as well in editable boxes where we could perform these functions as well. We wanted to do standard operations like zoom in, zoom out of the areas. We wanted to display multiple areas and points on the map extracted from particular user requirements. And we wanted to display the grid points from the different numerical model resolutions that we run here at ECMWF. And we wanted to adjust the selected areas while you are drawing on the map to fit the ECMWF different model grids. And this functionality is what we call the snap to grid functionality. So with these requirements, we hand over to Predictia, and they will show you what they've done. Fernando, over to you.
Yes. Okay, hello. So as Marta said, we are going to show a live demo of the application, and we are going to use also a PowerPoint. So we are going to jump between the live demo and the presentation. So first of all, we have to say that the map has been created using Leaflet. Leaflet is an open source JavaScript library for interactive maps. So we have just taken its object named map, and we have extended it, so we can extend its functionality, and we can add controls to it. So here we will have the map instantiated with Leaflet. An important thing is that here with Leaflet you can use the source to show the map that you want. Here we have used OpenStreetMap. To show all the functionalities of the plugin, we are going to show two examples. The first of the two examples is one that we start with a blank map with no figures loaded at the beginning, and then in the second example we will show a map with some points and areas loaded from a file. And to show all the functionality, we are going to show the different controls we have added to the map, so we can see all the different examples and possibilities of the map. Okay, the first of the controls is the drawing control. With this control you can add a point or a marker to the map, add a bounding box. You can remove them one by one with this tool, or you can remove all of them at the same time. So we are going to see some examples in the live demo. Here we can select the marker tool to create points. Once you have added them, of course, you can move them. And you can add here from here bounding boxes. Here we see like a message. What it says is that you have to click once, release the mouse, then you move it, you drag, and then you have to click again. This is done like this because it's easier for the mobile users. Because if you click and without release it, you drag, it's very difficult for the people who use this widget in the mobiles. So we can add more boxes here. And now we can remove them one by one. We click and we receive a confirmation message to delete it. It's the same for the bounding boxes. Or we can remove all the figures that are currently on the map at the same time. Okay. The next control we want to show is the grid control. What this control does is to show the user the different grid systems we have loaded on the map. In the future, maybe more grid systems can be added to this control. And when at the beginning we don't see any grids, but when the user selects one, if you have zoomed enough the map, you will see the points of the grid selected. You will also see while you are moving the mouse a red circle that focus on the nearest point of the grid that the user is with the mouse. And the most important thing about this control is that while you are drawing a marker or a bounding box and you are near of one of these points, the marker of bounding box moves to the point. That is the snap to grid functionality Marta was talking about. We will see better in the example. So here we have the control, the right top corner. So if I select one of the grids, you can't see anything, but you receive here a message that you have to zoom more the map. So we are going to zoom it, and you can see already the grid, the different points on all of the map. And if I move the mouse, you can see the red circle that is the nearest point of the mouse. So now, if I take the marker drawing tool, you can see that if I am near a point, it snaps, it adjusts to the point. If I want to move it later, it snaps. It's the same for bounding boxes. If I select the tool and I am near a point, the white circle adjusts to the point. So I click it, and then when I resize it, it adjusts to the points near. Okay, and now of course, if I want to resize again the bounding box, it's still snapping to the different points. Okay, and here, well, we can see the different grids we have loaded on the map, or we can hide them again. The next control is the geosearch control. What this control does is that you can search for an address in it, and it autocompletes the results while the user is writing. When you click on one of the results, it will draw a point on the map, except if it's a country that it will draw a bounding box. So we are going to see it. It's the geosearch. It's next to the drawing control. And for example, here we can look for London. We click on one of the results, and it adds a marker or a point on London City. But if we look, for example, for Italy as a country, and we click on the result, we see that it draws a bounding box. Okay. The next control is the legend control. This control shows all the figures, the points and the areas that are currently on the map, and they divide the points and areas in different sections. This control is not shown when you remove all the controls. With this control, you can focus on the markers and bounding boxes, clicking on the input fields. You can edit their coordinates from here manually, or you can delete the points and the bounding boxes just clicking on the cross icon. We are going to see it. For example, if we draw some points, we can see that that this control has appeared here, and we have the 2 points that we have added. For example, if I click in the input field, the map centers on it, and we see that it's highlighted with this blue effect. We can edit here manually. We write another coordinate, and when you click the enter key, it's moved to that coordinate. And as I said, you can delete it clicking here in the cross icon. It gives you the confirmation message, and you click OK, and it's removed from the map from here, from the legend control. You can also see that if I move one marker, the coordinates are updated here in the control. Is similar for the areas option. You can draw here a bounding box. Automatically the legend control goes to the area section, and here we can see the area with the north, west, east, and south coordinate. If I add more boxes, we can see here. We can focus from here, like in the markers option. We can click here, and the map centers on the box and selects it. We can change the coordinate from here too, like we did with the markers. For example, as you can see, it grows. Or in the same way, if I resize the box, the coordinates are updating here, and if I move it, the 4 coordinates change. And of course, I can delete it from the cross icon. Okay, I remove all of them, and the legend control disappears because there are no figures on the map. Here we wanted to show you how easy it is to instantiate the map in a web page. Or here you just have to import some JavaScripts and style sheets on your web page, and then you just have to add this div and this little code. Here what we do is we just instantiate the map, and then we can pass some configurable options to the map. Here, for example, we see that we can put where we want to center the map, and when it's loaded, the default zoom we want for the map. But you also can pass the literals of the application, the literals we have seen in the confirmation messages or in the legend control, for example. Now we are going to see the second example. In this example, as I said at the beginning of the presentation, we are going to see some figures already loaded. To load them, we pass a string with different coordinates to the plugin. in this case, we have passed a merge request, and we see in this slide we see how the merge requests are. This is only one instance of the coordinates, and we are going to read the grid and the area. So in this string we pass, we will have a lot of areas and a lot of markers, and we can divide the areas divide by the different grids we have read. So the user can select only one grid system, and he will see only the areas of that grid. When the user has everything loaded, he can add more figures, more points, and they will be added on the map and on the legend control. We will see that they are paginated because they are a lot of them. So the legend control paginates them, so it's easier for the user to manage them and also to the browser. So we are going to see this example. Here we have. Well, I have not said that these figures, these coordinates, we have loaded by file, but we will see later that they can be loaded by a text area of a web page or whatever the user wants. Okay, here we see that 5 pages of areas are loaded with 20 areas on each page. And here we have that there are like 29 pages with 50 points on each page. So here only we see on the map the points that are loaded on this page. But if we paginate, if we go to the next page, you see that the points are changing. And we can go to the last page of the points pagination, and we see that the last page is this one, the last point, sorry. And if I add one more here, it's added in this page. And if I go to the previous page, sorry, it disappears because it's not from this page. Okay. It's similar with the areas. Here we see all the areas, but if we select, as I said, this grid, now we only see 2 pages of areas that are the areas corresponding to this grid system. And if we add an area, it's the same as I showed you with the points and markers. It's added in the last page of the areas pagination with the same functionality as we saw in the previous example. Okay, here we want to show you also how we instantiate this map with these files loaded. Here we have the same functions as in the previous example, but now we pass this parameter. In this parameter are the coordinates that we saw on the map, represented as boxes and markers. What you pass here is a string. Why did we configure this with a string? Because we think that is more flexible for the one who wants to instantiate this plugin in its page. So he can decide if he wants to load a file or wants to load the content of a text input. So here we had to develop a little function to load the file with the shapes. In other case, maybe we have to develop the function to load the coordinates from a text area, for example. So we have finished to see the examples, but we want to show you also other functionalities that we have added to the plugin just to have the possibility to communicate the plugin and the web or the application that has instantiated. The first function is the get futures function that returns all the shapes that are currently on the map in a JSON format. And the second function is that the one to add the plugin on its web page can add listeners like this. So when a figure is created, is removed, or is modified, the listeners are triggered, and you can receive here this object that is the figure that has been created, modified, or removed. So the user can do things with this layer. And finally, we wanted to talk about the plugins we have used on the map because two of the controls have been created by us, that they are the legend control and the grid layer control, but others has been reused from other plugins that we have taken their functionality, or maybe we have modified it or just configured them. The first of them is the Leaflet PM. It's the drawing control. Here we have selected only some of the tools: the marker tool, the bounding box, and the remove tool. And we have added the other remove option, and we have deleted the options we didn't want. One thing we wanted to say here is that we have developed the possibility of drawing polygons, not only bounding boxes and markers, but also polygons. But at this moment, this option is not available because we didn't have the way to map these polygons with the ECMWF requirements. So now it's not able for the user. The second plugin we have used is the geosearch. This is an interesting tool that you can configure the source. As I said, with the map source, we have used OpenStreetMap, but you can select other sources. They are available. And then, well, we have used another little plugins to have a better user experience in the application. One is the marker highlight. It's just you saw that you highlight with a blue effect on the markers that are selected. Then we have the message box to give some information, some aclarations to the user. Then we have the canvas layer that we have used to draw all the grid systems in the full map. And finally, the suite alert, that it's just a plugin to have some beautiful alerts to give the confirmation messages to the user. So that's all about the live demo, and I pass the turn to Megan.
So the widget will now be integrated into ECMWF's web applications used for the pricing and delivery of meteorological data to our users. So the example shown here is from our new requirements editing interface for the specification of real-time meteorological requirements. In this case, the widget will be integrated as a pop-up displaying all the points and areas that a user is receiving real-time data for. For our data pricing tool, the widget will also allow the selection of multiple points and areas, and will calculate the costs associated with these areas for different resolutions. The widget was developed based on a Scrum Agile framework,
the premise of which is incremental development, testing and deployment on a weekly basis. We achieve this with weekly video calls where we would constantly review the priorities of the features, discuss the best way to implement the features that we needed, and raise any bugs that had been found during our weekly testing. Our day-to-day communication was via Jira tickets, which were created for different tasks and bugs, and this allowed the day-to-day tracking of the progress of the project. We also reviewed the progress of the project halfway into the development by gathering internal feedback from ECMWF colleagues. And to give you an idea of the amount of work that was required for the project, we have reached a total of 64 commits and 36 Jira tasks over the past 4 months. And with this being an agile-based project, we developed feature by feature. So some further features that we would like to consider for the future are polygons, which were implemented to begin with, but we've removed these for now as we still need to find a way to map these polygons into ECMWF requirements. Frames, which are 2 overlain bounding boxes used to define a border area, and these are particularly used for limited area models. We also want to consider the rotations of areas and the land-sea masks, which is the ratio of land and sea at each grid point. And finally, layers. So we want to find layers to translate all of the countries in the map into English, because currently the countries and cities are displayed in the native language. And the code, the Git repository, is publicly available. And if you'd like to contact myself, Marta, or Julia about the project or the Predictia developers, then our emails can be found here. Thank you for listening.
Okay, so thanks Fernando, Megan and Marta for the presentation. So this was the first presentation of this week of webinars. If you're interested, you can also join tomorrow. There will be another webinar about a project as part of the Summer of Better Code. It will be about netcdf files managed as a or represented as a virtual file system. So we would be happy to welcome you back tomorrow at the same time and also the same access link. And thank you and have a good rest of the day. Bye.
Bye.